Sensory analysis on steeping methods of preservation of broccoli var. Sadhana. Abstract. The research work was taken up to study the sensory characteristics of broccoli var. Sadhana preserved by steeping methods in the region of Mohanpur, West Bengal. Different steeping solutions were prepared by formulating 5% brine, 8% glacial acetic acid and 1000 ppm kms, potassium metabisulphite. Broccoli samples were prepared by hot water blanching, 30 seconds, steam blanching, 1 minute, and microwave blanching, 800 watt, for 30 seconds and preserved in steeping solution for storage and sensory analysis for color, texture, smell, taste, and overall acceptability were carried out during the 5-month storage period. The highest score for smell, taste, and overall acceptability was recorded in broccoli microwave blanched and steeped in 5% brine plus 8% glacial acetic acid plus 1000 kms during the 4-month storage period. Keywords: broccoli, brine, color, glacial acetic acid, smell, taste, texture. Introduction. Broccoli is one of the highly perishable crops which has a very short shelf life. The season of availability of this crop is very short, so it becomes very important to preserve it for off-season. Broccoli can grow well during winter season in India. So there is good scope for export during this period if grown abundantly to Gulf and other developed countries with unsuitable climatic conditions. 1. Broccoli is a highly priced vegetable and famous for its vitamin, antioxidants, and anti-cancerous content and health-promoting phytochemicals. 2. Broccoli contains on an average 1.26.24 mole of glucosinolates/G. Fresh weight. 3. Preservation of fruits and vegetables in a steeping solution involving permissible chemical preservatives and other food additives is one of the easiest and cheapest processing technologies in developing countries like India. Brining or salting is the oldest and cheapest way of preserving vegetables, meat, fish, and other foods whilst maintaining a fair amount of their nutritional value. 4. Steeped products can be utilized further for making various value-added products. Preserved material can be stored for 6 to 8 months at ambient temperature and beyond 1 year at low temperature, 13°A degrees C, for the preparation of various products. So, the research work was carried out to preserve broccoli in steeping solutions to determine the best steeping solution by studying the sensory characteristics of the product during the storage. Materials and method. Broccoli CV Sadhana grown in the Horticultural Research Farm, Manduri, WB was collected for the study carried out in the laboratory of the Department of Post-Harvest Technology of Horticultural Crops, Bidhan Chandra Krishi Viswavidyalaya, WB. Broccoli CV Sadhana were harvested when they were fully grown but tender and dark green in color with unopened florets weighing about 500 to 600 grams and brought to the laboratory immediately. Leaves were trimmed and cooled to room condition for 3 hours. Fresh broccoli heads were chopped into pieces, 4 2.5 square centimeters dimension, along with the stalk and blanched by different methods separately filled in steeping preservative solutions as stated below. Blanched pieces were then dipped in cool running water and spread evenly on a plate lined with tissue paper for few minutes under fan to remove excess moisture, after which they were immersed in jars filled with steeping solutions prepared from boiled and cooled filter water, and the following solutions were made and filled. The jars were sealed properly and stored in dark room for 5 months with temperature ranging from 1938.9 degrees C and RH 100 to 79% during the storage period. Sensory analysis. Sensory evaluation for color, smell, texture, taste, browning, and overall acceptability, 5-point hedonic scale, were recorded at regular interval during the entire storage period. 5. The scores for each parameter were randomly collected from students in the college campus in respect to the scorecard being formulated for the analysis of the product. Results and discussion. Color score decreased progressively during the storage of steeped broccoli in Table 36 irrespective of the types of blanching methods and the steeping solutions. However, treatments consisting of 5% brine plus 8% GAA plus 1000 ppm kms reduced the rapid decrease of color score as compared to those using only 5% brine. All treatments gave significant effect on the color score of steeped broccoli during the storage period. However, microwave blanched broccoli plus 5% brine plus 8% GAA plus 1000 ppm kms, T9, gave the highest scores of 4.73 and 4.47 on 3 and 4 days after storage, respectively, followed by hot water blanched broccoli plus 5% brine plus 8% GAA plus 1000 ppm kms, T3, during the storage study, while the minimum score of 4.10 was noted in steam blanched broccoli plus 5% brine plus 8% GAA, T5, on the 4th month of storage. Just after blanching, the color of broccoli was visually observed to be bright green color. The brightening of the green color after blanching is due to the elimination of intracellular air and angra of blanch water and cellular fluids as a result of cell disruption. The addition of acid during the equilibration process had a profound effect on green color, producing an olive green color. The addition of citric acid sufficiently lowered pH to induce and accelerate pheophytonization. 6. Pheophytonization is a process wherein two H and ions displace Mg++ from the porphyrin ring of chlorophyll, and convert chlorophyll, green, into pheophytin, olive green. This acid effect was most detrimental to broccoli color. Green color was maintained for all the treatments during the storage period except at T4, steam blanching plus 5% brine, except which showed the lowest score of 3.73 at the end of storage. The combination of 5% brine and 8% GAA with 1000 ppm kms gives the best color for every type of blanching given. The common way of preventing enzymatic browning in fruits and vegetables was achieved by dipping or immersing them in anti-browning agents. 7. It was mentioned that microwave blanching preserves better the nutritional value of the product. 8. Smell. Table 1 indicated the score for smell decreased steadily during the storage of steeped broccoli irrespective of the blanching and the steeping solutions. However, steeped broccoli reduced the smell score in storage as compared to that which used only 5% brine. During the last month, the smell score was maximum in microwave blanched broccoli. Plus 5% brine plus 8% GAA plus 1000 ppm kms, T9, with 3.77 on 4 Moss, followed by steam blanched broccoli plus 5% brine plus 8% GAA, T5, while the lowest score of 2.57 was recorded in steam blanched broccoli plus 5% brine, T4, on 4 Moss, month after storage. Decreasing trend of smell score was found during the storage period. The highest smell score of 3.77 was retained in T9, MWB plus 5% brine plus 8% GAA plus 1000 ppm kms, at the end of storage. Acidic smell was prominent among the good sample, which can be removed by washing in plain water. Most of the aroma came from acetic acid, which consists of numerous volatile and heterogeneous chemicals that easily evaporate at ambient. 9. Texture. Table 1 showed the decreasing trend of smell score during the storage period. There was significant change of texture due to different blanching and steeping solutions used. Steeping blanched broccoli with 5% brine, 8% GAA and 1000 ppm kms resulted in higher texture score as compared to those where only 5% brine was used. The highest score of 4.53 was recorded in steam blanched broccoli plus 5% brine plus 8% GAA plus 1000 ppm kms, T6, on the last month of storage, followed by microwave blanched broccoli plus 5% brine plus 8% GAA plus 1000 ppm kms, T9, while the lowest score in steam blanched broccoli plus 5% brine, T4, on 4 MAS. The texture remained good in all the treatment combinations having 5% brine plus 8% GAA plus 1000 ppm kms irrespective of type blanching done. However, among the treatments, the best was obtained in T3, HW blanching plus 5% brine plus 8% GAA plus 1000 ppm kms, at the end of storage. There was some evidence that acidified vegetables retain a better texture than non-acidified ones in turnips, so acidification contributed to retention of firmness. 10, in vegetables 11 and in carrots 12. Taste. From Table 2, it was indicated that various steeping solutions had significant effect on the taste score of steeped broccoli during the storage study. The taste score reduced with the progress of storage days. Combination of various steeping solution reduced the rate of decrease of taste score as compared to those where only 0.5% brine was used as steeping solution, and combined steeping solution was observed to be more effective than only 0.5% brine in reducing the decrease of taste score. The highest taste score, 4.90 to 3.70, throughout the storage period was noted in microwave blanched broccoli plus 5% brine plus 8% GAA plus 1000 ppm kms, T9, followed by 3.63 in steam blanching plus 5% brine plus 8% GAA plus 1000 ppm kms, T6, while the least score was observed in taste score. The highest score for taste on month 1 was evident in T3, HW blanching. Plus 5% brine plus 8% GAA plus 1000 ppm kms, with 4.77 followed by, and T8, MWB plus 5% brine plus 8% GAA, having score of 4.73, 4.70, and 4.60 respectively, while the lowest score was in steam blanched broccoli plus 5% brine, T4, which reduced from score 5 to 2.33 throughout the storage period. At the end of storage, the best taste score, 3.70, was in MWB plus 5% brine plus 8% GAA plus 1000 ppm kms, T9. Taste also remained moderately acceptable for hot water blanching plus 5% brine plus 8% GAA plus 1000 ppm kms, T3, among other treatment of hot water blanched and steam blanching plus 5% brine plus 8% GAA plus 1000 ppm kms, T6, among the steam blanched broccoli treatments. Pre-treatment of Brussels sprout by microwave, 700 Watt for 5 minutes, have been effective for preserving product properties compared to hot water blanched, 1000 C for 3 minutes, 13. Overall acceptability. Steeping method gave significant effect on overall acceptability score of broccoli during the storage period in Table 2. The score declined with the advance in storage period. With the inclusion of all the steeping solution, the rate of decrease of score was lower as compared to those where only brine solution was used. Among different treatments of blanching and steeping methods, microwave blanching and steeped in 5% brine along with 8% GAA and 1000 ppm kms gave the highest score on the last month of storage, followed by steam blanched broccoli and steeped in 5% brine, 8% GAA and 1000 ppm kms, and broccoli hot water blanched and steeped with 5% brine, 8% GAA and 1000 ppm kms with scores 4.50, 4.43, and 4.37, respectively on 4th month. There was no visible decay in the samples during the period of study. The high acidic condition due to GAA may be responsible for the inhibition of any microbial growth. The lower value of acceptance may also be related to the bitterness of cruciferous crop 14. One objective of the acidification is to prevent growth of Clostridium botulinum, which does not produce toxin at pH below 4.615. No visual evidence of spoilage was found in acidified vegetable packs for 60 days storage when examined for turbidity, gas production, and mold growth visually, while chemical test showed no lactic acid or ethanol in the sample 16. Conclusion. Among the various steeping preservative solution for broccoli during the 5-month storage period study, it was found that broccoli blanched in microwave, 800 WATT, for 3 minutes and steeped in brine solution with glacial acetic acid with 1000 ppm kms gave the best sensory score, overall acceptability, followed by broccoli blanched in steam and hot water with same steeping preservative solution. Consumer preference is always directed towards the color, texture, and appearance of any product. This method could prove to be an alternative method to prevent the loss during glut season of broccoli, which could otherwise contribute to the post-harvest loss, while at the same time ensure the availability during the off-season if the preservation could be done in the steeping solution without much loss in the sensory characteristics.